All right, so for today, what we want to do is to talk not so much about measures of central tendency, but rather measures of variation. So measures of variation do include your range. There's another one with a box plot or box and whisker graph, which are the interquartile range. And there's another one with what we call a distribution curve, and that's called a standard deviation. So we might not quite get into standard deviation very much, but we'll talk about what it is. Okay. So first of all, we want to talk about range. We all know range is the highest, right? The largest minus the smallest. So in order to do these things, we do like to get them in order from least to greatest and go from there. So if we're going to do this first one right here, we can need to put these in order. And so we're going to start with the smallest number, which is a 65, and another 65, and then a 68, 77, 78, 84, 95, and 96. So now these are in order, so we can definitely tell that the range on here is definitely 96 minus 65, which is 31. Now to do what we call a box plot, which we need to do in order to find the interquartile range, we have to basically break the data up into 4 equally populated segments. So if I'm going to do that, I'm going to start out by finding the median. And the median happens to be right here between the 77 and the 78, 77.5. So each side has 4 different pieces in it. From there, we're going to repeat this idea, and we're going to find what we call the quartiles. And so I want to break each side into equally spaced. Depending on what you're looking at, they might call it quartile 1, they might call it quartile 2, but right between here is actually the mid quartile of 66.5. I could add those up. 133 divided by 2 is 66.5. Very similar over here. The end of the third piece, or the upper quartile, would be between there, which is going to be 89.5. So when we have this, typically what we have is I know that the difference or the interquartile range is right between these two. So if I took the 89.5 minus the 66.5, that turns out to be nice 23 is my interquartile range. So we don't have a lot of spacing in there. To come up with a box plot or box and whisker, we would have to figure out approximately where we would need to be. My lowest value was a 65. Then I was at 66.5. The median was at 77.5. Upper quartile is at 89.5. And then we're at 96. So interquartile range in a way is like the length of this box. The things that we can tell here is each segment here represents 25% or 1/4 of the data as indicated. If I had a sort of say whisker that was really long, it might mean that we have an outlier. This set of data right here does not have an outlier, but an outlier is found by taking 1.5 times your interquartile range and seeing if it's more than that far away from the box plot. So let's look at the next one. The next one, putting it in order from least to greatest, is a 10, a 33, 34, 37, 43, 45, 45, 50, and 56. So we want to do the same idea here. I could find the range. The range is least to greatest, greatest to least. 56 minus 10 is 46. In order to do the interquartile range, we have to locate those items, starting with the median. Now this time I have one number in the middle. And when that happens, we don't count this one when we go to find the quartiles. So 43 is my median. Okay. Looking at each half, what I have here is in the middle of these two, my lower quartile in the first quartile is there. Here at 47.5 is the other one. And we need to put these on a number line as best we can. We're going, and we'll just go on these marks. The important thing about putting it on a number line is it helps us identify what is more common as opposed to everything looking like it's equally spaced. So now we have this value of a 10. We go all the way to 33 and a half, and 43, and 47 and a half, and then up to 56. So right now what we're going to see here is my box plot has this really long piece. And that tells me that I might actually have an outlier. So let's go ahead and find the interquartile range. So I'm going to take 47 and a half minus 33 and a half, which gets me right at 14 for my interquartile range. If I take 1.5 of that, what we're looking for is where does 21 away from here fall? Okay, something is more than 21 away because 1.5 times 14 is 21. Then that point is an outlier. So from 47 plus 21, that's going to be 68. This one does not have any outliers up this way. If I go 21 away from the 33, that would actually tell me that I would be at 12.5. Do I have anything further away than 12.5? And yes, I do, which means that 10 is no longer going to be my lowest value or part of my whisker. It's actually a different value. And so this really only goes to 33. It's considered an outlier, oftentimes marked differently. So the red is my final graph. We have our range, our interquartile range. The other piece that we would have is called a normal distribution curve. Sometimes it's also called a bell-shaped curve. It says all of our data is within this item, and it's most common for the majority of your data to happen in the middle. Normal distribution curve is like ideal, in which case your mean happens to be the median, and it happens the most. So it's when all of your measures of central tendency line up. That's called the normal distribution curve. What we do with that is we find a standard deviation that kind of normalizes the spacing on here, which used to be a big piece of how we grade, but that might come into a discussion a little bit more on another day. If it looks like this and most of the data is down here, this is either called positively skewed or right skewed, if you would. I would need to move it to the right. And if it's all the way over there, we would either need to subtract something to make it look more normal, or we would call that left skewed. Means it's not normal. Usually if we have great data, it's going to all line up. Our mean, our median, our mode. And we're going to find a standard deviation to work with. Otherwise, our other measures of variation, we might use a box plot to show it, with our range, our interquartile range, and our standard deviation. Sorry about that.